Once again, a very good evening, everyone. Now we'll move to the next session, that is session two, Introduction to GIS and Remote Sensing in Civil Engineering, and it will be done by uh, Dr. Pawan Kumar Mishra, Senior Director, Construction Industry Development Council. I would like to introduce our next speaker as is Dr. Pawan Kumar Mishra. He is currently working as a senior director, Construction Industry Development Council, which is established by the Planning Commission, Government of India. He has served various central and state government organizations, having more than 30 years of vast experience in construction industry at different level. He has headed the Indian Construction Cooperative Federation as managing director and Chhattisgarh Nirman Academy as director. His areas of expertise are project management, skill development in construction sector, GIS and remote sensing. He is pioneer of GIS-based CES assessment for the Labor Department, Government of Uttar Pradesh. He has headed the team working on GIS-based base map development and urban planning. His advancement qualification include a doctorate in civil engineering, postgraduate diploma in project management, and masters in business management HR. He is a fellow of several premier professional institutions like the Institution of Engineers India, Indian Geotechnical Society, and life member of Indian Road Congress, Indian Building Congress, Indian Concrete Institute, Indian Society of Geomatics, Indian Society of Remote Sensing, etc. He has more than 10 research papers to his credit, published in national and international journal, and keynote speeches and plenary presentations in national and international conferences. He has written two books in the area of construction engineering, published by the international publisher. He is known for his collaborative spirit. Dr. Mishra actively engages with industry professionals, researchers, and policymakers. He serves on advisory boards for key industry organizations and plays a pivotal role in shaping the discourage around the future of civil engineering. Now, may I please request our speaker to join the session, and I will hand over this session to him. Please, sir. It's our privilege to have you as a speaker for this 6 days online FDP, and your session is on Introduction to GIS and Remote Sensing in Civil Engineering. Please, sir.
Thanks, Engineer Ankur.
Sir, your voice is not clear actually.
My voice is not clear. Is it coming now?
Yes, sir.
Better than previous one?
Far better.
Okay. Basically, I have joined your sessions in the beginning from the inaugural session, and before a learner, definitely I will also join other sessions because you have arranged really very good speakers and from the
Actually, sir, your voice is not coming. It is coming from very far. Actually, it is not clear. Sometimes it is coming and sometimes it's not coming. It's a bit disruption there.
So just give me a few seconds. I am going to connect my headphone. Just give me few seconds.
Okay. May I please request everyone just to mute yourself?
Ankur, now my voice is clear or not?
Yes, sir. Now it is.
Is it clear now?
Yes, sir.
Fine. So definitely, Engineer Ankur, I am extending my sincere thanks to you for giving me this very excellent opportunity to share some knowledge among the young engineering faculties. And as you have given me the topic to cover the introduction of geographic information system and remote sensing, and especially focusing in the area of the construction industry. So definitely, I will try my best to to give the fundamentals of the geographic information system and the working in the geographic information GIS, working and developing. So my total lecture will try to focus on the fundamentals of the GIS. The challenge of my session is that it might be possible that some participants are very senior person or may have very good exposure and knowledge of the geographic information system and remote sensing, but I will try to bring the session from the fundamentals to the higher level of the GIS in construction industry. So just I am going to start my presentation. Just give me a few seconds. Is this visible, Engineer Ankur?
Yes, sir, perfectly.
Okay. There are two questions in the online webinars. My wife is audible and my presentation PPT is visible. So with the grace of God, everything is fine. I welcome all participants and organizers, and especially I extend my thanks to the All India Council for Technical Education. Personally, I am associated with AICTE in different capacity. So give us the permission, with your kind permission, I am going to start the presentation and the discussion. My topic is Introduction to GIS and Remote Sensing in Civil Engineering, and the session has been divided in three parts to cover the entire topic. First part is the fundamentals. I will try to discuss the fundamentals and the development of the geographic information system and remote sensing. The second session is software, related to the software applications and some advanced topics. The third session will cover the implemented projects, the projects implemented by me. So dear participants, now I am going to start the fundamentals of the geographic information system. Basically, this session is focused on the learner of the GIS. This session, the experts may feel that this is the basic information and knowledge, but as the assignment given to me, I will I am going to give the fundamentals of the geographic information system. So the geographic information system, let us start with its history, its background. We see Roger Tomlinson as father of the geographic information system. It was started in 1960 when Roger Tomlinson was deputed in Ottawa City in Canada and given assignments for the land usage, especially the underground services and availability of the information. From that, GIS has traveled a very vast journey, and fortunately now we have very advanced satellite systems, very advanced computer systems, very advanced calculation systems, and other technologies. So by integrating all these facilities, now GIS is really very good and excellent tool for our for our day-to-day problem solving, from our Google Map, Earth Map, for our COVID management, like other apps, and to the very advanced problem solving applications and tools. So, dear participants, as this session is focused on the beginner learners, I have prepared the presentation in the format of the question and answer. So definitely, when we start the learning of the GIS, the first question comes in our mind, that what is GIS? What is the Geographic Information System? Basically, the first question comes in our mind, that what is GIS? Basically, there are several misleading concepts that GIS is a software, but it is not limited to the software only. Basically, there are several definitions, technical definitions. We can go through all these definitions. uh, in summary, as a general definition, we may say that GIS, Geographic Information System, is a system that is used for creating the words are very important. We will discuss in detail later on, but here at this point, I am using some terms I am using some important terms. GIS is a system that is used for creating, storing, and managing geographic information. Creating, storing, and managing geographic information system to solve problems and to take the decisions. Here I have coined 4 5 terms. First is creating, second is storing, and third is managing what geographic information. For what purpose? To solve problems and to take the decision. The best part of the geographic information system is to have the facility to assist to take a good decision based on the input data. We will discuss later on, but here it is not only a software, it is not only limited to the software, but it covers a very large area. Definitely, I hope that there is facility to share the PPT to all participants. I am moving little bit faster. You can go through all definitions and technical definition. Geographic information system are computer-based system that modify users to gather. Again, I am repeating, to gather, to store, and to process, to analyze, and to present spatial knowledge. Here I am expanding the scope. First, gathering the data, gathering the geographic information, storing the data, processing, analyzing, and presenting the reports, presenting the spatial knowledge. So all these are the definitions basically, but here the question arises. Here question arises, what are the spatial data? Because I am covering the beginners knowledge. I am providing knowledge to the beginners of the GIS. The question is, what is the spatial data? Basically, any element of our world, any element of our world can be described in two ways. First one is the spatial data, and the second one is the non-spatial data. First one is the spatial data, and the second one is the non-spatial data, means the attributes. For example, if we will have to describe a tree, I'm taking one simple example to, to describe the spatial data and non-spatial data. If we will have to describe a tree, then there are two ways. First one is the location. The question is where is it? Where is it? The question is where is it? And the second description point is what is it? What is it? The response of the first question, where is it, is spatial data. Means if any data describing any object location on the surface of Earth, then it is spatial data. Otherwise, it is non-spatial data, it is attributes. For example, if we are describing tree by the latitude and the longitude, then it is a spatial data, and the other features like the type of tree, age of the tree, height of the tree, condition of the tree, color of the tree, all these are the attributes or non-spatial data. So dear participants, always keep in mind if any data having the latitude and longitude or having information related to the location of the object on the earth surface, then it is spatial, otherwise it is non-spatial. The next point is that GIS comprises of four basic ideas, four main ideas. First one is the creating geographic data. Second one is the managing it in a database. Third is analyzing and finding patterns. Fourth one is the visualizing it on a map. We will study more in detail during our executed projects. Basically, from first flight to the last flight, there may be possibility the repetition, the more elaboration, more detailing. So just to connect these points, we will go in detail later on. So these are the four main ideas of the geographic information system. When we go for the types of GIS, how many types of GIS we are working in our life in the area of GIS? There are four dimensions GIS. The second one is multimedia GIS. The third one is the web GIS. Fourth one is virtual reality GIS. I am skipping these slides because all may understand, all participants may understand these very common terms. Four-dimensional GIS, multi-dimensional GIS, web GIS, and virtual reality GIS. The next, this is the very important question because try to remember my first quote that GIS is not only limited to the software, but it is a very wide range. It is a very big system having several components. Software is one of them. So the next question is that what are components of GIS? Dear participants, whenever I give the lecture on the understanding of the GIS, I always try to communicate communicate to give the description of the GIS through its different key components. So, dear learners, there are five key components, and by combining all these main components or key components, we can study the complete system of the GIS. So my whole lecture, the coming lecture, will be focused on the covering all these five key components. So that if anyone has no any idea of the GIS, that participant could also understand the what is GIS. So there are five key components. We will cover one by one. There is no any importance of any key component. Don't be confused that first component is more important than the second or third or last component. So, so the first component is the hardware, second one is the software, third is the people, fourth is methods, and fifth is data. As data, I am coming on the data, so that I will give you the some information, important information. Basically, in GIS, data, GIS stores location data, spatial data. When we are talking about the data, that means the spatial data. Preferably, we are talking about the spatial data. So GIS stores data in layers. What is layer? We will discuss in detail in coming slides. So here, each data set has an attribute table that stores information about the feature. Data may be categorized in three categories. I am talking about the GIS data related to the GIS. First one is the raster, second one is the vector, and the third one is the TIL. Here in our coming slide, I will give you the details of the interlinking of the data and data generation and data management. So the first data, in brief, I am trying to cover the entire spectrum of my lecture, so I am moving little bit fast. So the raster data is basically the simplest form of data. Interestingly, any photo, any image in its original form is a raster data. Even our scanned copy, our photocopy is also a form of the raster data. Raster data are digital aerial photographs, imagery from satellites, digital pictures, or even scanned maps. These are the different high resolution images. Basically, now we are very fortunate, as Professor Agrawal, director, today's chief guest of this FDP, well said that now we have very good facility of the satellite imagery. Now we can take imagery having the resolution of 0.30 meter. Basically, earlier when we were started the working, we were receiving the data having resolution of more than 1 meter or like poor resolution than that. So, as Professor Agrawal said, we have different systems of satellites. You can go through all these satellite systems because for different purposes and for different resolutions, we are taking data from different satellites. I have tried to summarize different types of products and having their resolutions or height of the satellites from the Earth surface. These are the history of the, let me say, this is the history of the procurement of the satellite images. Earlier, we were getting the 10-meter resolution like this, and now we are having the data satellite imagery for 0.5 meter or 0.3 meter. we use different data for the different purpose, as Professor Dr. Agrawal said in his inaugural lecture. So I am skipping all these. Even we are very fortunate that we have very high resolution imagery. We can differentiate any object if that object has a dimension of more than 30 centimeter, and we are using. I will give you the example in my implemented project that is related to the urban development planning, uh, related to the base map and master plan, and in that to describe the detail of the different structures, constructions, building, we are using high resolution data. So the next type of data is vector data. Vector data is comprising three geometrical characters. First one is the points, second one is the lines, and the third one is the polygon. Vector data is comprising three geometrical characteristics: points, lines, and polygons. These data are created by, again, one important word is coming in my lecture. These data are created by digitizing the base data. Digitizing the base data. This is the working of the geographic information system. Dear participants, we were receiving data in the form of raster. Try to remember my statement. We are receiving satellite imagery. We are capturing any photo, or even we are taking a scanned copy of any map. All these will be in the form of raster data. Here we are saying that vector data is comprising three geometrical features, three geometrical characteristics. First one is the points, second one is the lines, and third one is the polygons. So here the term, the keyword of the GIS is coming in the picture. What is that? That is the digitization of the data. Because, because in GIS system, in geographic information system, we work on the vector data. We work on the vector data, and we receive data in the format of raster. So what we will do? First, we will do transform the raster data into vector data. We convert raster data into vector data, and the process is the digitization. So what we will do in software, in the first step, we digitize, we convert raster data into vector data. How we will convert? We will study in the software. So, dear participants, this is the second type of the data, that is the vector data. All these are the images. Third type is the scene data. We will go in detail if time will permit. Next key component, is the hardware. Basically, I am not going in detail for the hardware, because in these days almost we have very good hardware. Even in our mobile we can use GIS based applications. If we are using our mobile for the locations, for the cab booking, all these are based on the GIS system. All these are working on the GIS platform. Sorry. The third component of the GIS is software. As Dr. Agrawal said, there are several softwares. More than 100 softwares are available in the market. But I am quoting here the words said by Professor Dr. Agarwal, that the mostly used software are ArcGIS and the QGIS. I will describe both softwares in detail, but here we are going to study two softwares. First one is the ArcGIS and the second one is the QGIS. The fourth key component is people. People means anyone who is involved in the project, in the system. Project owner, software engineer, or anyone, any stakeholder is under this key component. The fifth
Please unmute
component.
yourself, everyone.
The fifth key component is methodology or algorithm. I will definitely explain in detail for the beginners. If anyone is interested to start the working in GIS from zero, then that participants could go through my presentation to understand the process, the methodology, and the algorithm of the GIS working. How we will start working in the GIS, I will definitely give you in detail. So, dear participants, we have given brief introduction of five key components: software, hardware, people, methods, and data. We will discuss one by one in more detail if time will permit. So the next question is how geographic information technology works. The question is how geographic information technology works. Basically here I would like to give a brief of three terms. These are basically very important terms. First one is the Global Positioning System, GPS. You may be aware about all these terms, but just to link the knowledge, I am describing these three terms. First one is the global positioning system. What is global positioning system? A system of Earth orbiting satellites which can provide precise location on the Earth surface in latitude and longitude coordinates are equivalent. The second term is remote sensing. Use of satellites or aircraft to capture information about the Earth surface. Digital ortho images, a key product. Here, very interesting point. I would like to share one very interesting point. God has given us a very good remote sensor. What is remote sensing? If anyone capturing the data, if anyone collecting the data without having physical contact to the object, without having physical contact to the object, then this process is remote sensing. If I am repeating my statement because there are disturbances. If anyone is capturing data without having any physical contact to the object, then it is remote sensing. God has given us very good remote sensor. For example, our eyes, our eyes our eyes collect the information, collect the data
Hello.
without having any physical contact to the object. Our ears collect the information, collect the data without having any contact to the object. So remote sensing is this. The next topic, the next term here, just I am trying to connect the different terms. The third one is the geographic information. We are going to study GPS and remote sensing are sources of input data of a GIS. This, this is the line. GPS and remote sensing RS are sources of input data for GIS. And then we will study the GIS. What can GIS be used for? Basically, in my opinion, nowadays, GIS is being used for almost all area and all objectives of any human being. Let me say, as previous expert was describing climate control, climate change, we are also using in that, and even our day-to-day working for location map or for cab booking or for our health app. If, let me say, in each and every objective of our day-to-day life, we are using GIS. I am very confident to say this statement. But my topic is to cover GIS in construction, GIS for civil engineer, or GIS for engineer. Let me say GIS for engineers. So I have tabulated different applications of the GIS in the civil engineering, in the construction. You can go one by one for civil engineering, for business, for environmental science, for real estate, for healthcare, for education administration, for advertising industry, for telecommunication industry, for for traffic planning. We will go through all these applications with if time will permit. For urban planning, management, and policy, because I am working in this area with the applications of the GIS, we are doing the zoning, subdivisional planning, land acquisition planning, economic development, code enforcement, several codes like municipal development, rural development, urban development, housing renovation programs, emergency responses, crime analysis, tax assessment, redistricting, or defining different cities boundaries, and we studying the future development. Even in our smart city, we are working, let me say, that we have transformed the working in the smart city just by using GIS. I would like to request that please go through the website of the Varanasi Smart City. You can visualize the strength and capability of the GIS. So analysis of election result, predictive modeling, all these several applications. Let me say that in all area of life, we are using GIS. All these are the different sectors where we are using GIS. I am not going in detail. I am just skipping all these areas. You can go through my PPTs to have a better idea how we are using GIS in these sectors. The next question is, what problems can GIS solve? Basically, as a GIS expert, what I am trying to repeat that any problem can be solved by the GIS. For example, if you are going to study in the area of hydrology, we can study each and every aspect of hydrology, each and every aspect of hydrology just by using GIS. So I am not going in detail. The next important question, I am repeating several since beginning that GIS is that, GIS that, GIS can solve any problem, and GIS is using in every our day-to-day life. Why GIS is unique? Basically, GIS has three features, three important features. First one is GIS handles spatial information. What are in spatial information? I have just discussed it. This is the unique platform, unique system which is capable to handle, to store, to monitor, to analyze both types of data in one system. This is the unique feature of the GIS. GIS is capable to handle spatial and non-spatial data in one system. This is the uniqueness of the GIS. The next, GIS makes connections between activities based on spatial proximity. When we book a cab, we can visualize, we can see in our mobile that cab, the location of the cab, how far that cab is situated, located at this time, how much time that will take to reach to us. Even during our map, location map for the traveling, we can see the traffic jams, whether there are traffic jam or not. And the third is decision making. The really unique feature of any system, GIS supports supports to take best decision based on the input uh, data entered in the system. For example, during our location map or our location Google map, we can ask the system which route is the shortest. Or several times, system reply give us the options that this route is free from congestion, or this route has more congestion, or this route may take lesser time. So the GIS, the uniqueness is that GIS support us to take the best decision depending on the data available to the system. So these are the uniqueness of the GIS. The next question is, what are the advantages and disadvantages of GIS? What are the advantages and disadvantages? Basically, we have discussed the several advantages of the GIS. We have discussed the uniqueness of the GIS. So I am again not going in detail to describe advantages one by one. But I have listed in my PPT. You can go through all these. I have I have prepared a small table just to give you the idea. When we were working for the municipal corporations for their property assessment and for this and that, we would have to convince the authorities to bureaucrats that why GIS is necessary to incorporate in the municipal corporation. Nowadays, almost each and every municipal corporations or each and every authority are using GIS, but try to understand our situations when we were trying to convince municipal corporations to development authorities before 15 years to incorporate GIS in their property assessment to tracking the legal or illegal constructions or to planning the development of the city. So for that, we have prepared this type of table having more than 50 parameters. Some of some of them are low cost and less manpower required. I am talking about the advantages of the GIS. Data can be managed efficiently, transparency, special query about the parcels, about the defined area are possible. Data integration and overlay from different sources can be managed with less time and cost. Graphical and map output and a display is possible, and it is cheaper than the manual or traditional system of the survey or uh, of the survey or study. Search type computers. Initially, we would have to go either on the location or in the file to have information of any property or any location or for any construction entity, for any asset, let me say. But by using GIS, you can see each and every detail of any property, any asset, just by clicking your mouse in your system. We have developed this system for the UP government and for other governments that the authorities can see the details of any property for any land just by clicking in their system. And the second one is the if fixing the location is possible, very precise, very convenient, and available location on the map. All these are the advantages of the GIS over traditional survey or traditional study. Now we are coming on the disadvantages of GIS. Basically, uh, no system could be said that this is the foolproof or perfect system. GIS has several disadvantages, but as a GIS expert, I am saying that these disadvantages are not really disadvantages. If anyone saying that GIS requires a very high skilled manpower, then in my opinion, this is not disadvantage, because if you are using any advanced system, if you are going to launch a satellite, then definitely you will have to very experts in that area. If it is costlier, if we say that it is costlier, then again, if any system is giving you very precise information, very precise reports, lesser probability of the human error, then definitely it will be economical in a longer run. The next disadvantage is that If our area of study, I am talk, uh, talking about the location of the survey of any area. If the area is smaller, very small, then it may be costlier than the traditional system. Fine. The most serious disadvantage, the most serious disadvantage of the GIS is that point number three. Since the earth is round, try to understand my this point. Since the earth's surface is round, and so there would be geographic error that will increase as you get in a larger scale. Because when we receive the satellite imageries, when we will receive the satellite imageries will be two-dimensional. Means it is very difficult to capture the impact effect of the curvature of the earth. But nowadays we are taking care of this disadvantage. So, dear participants, it's my humble request that please go in the area of the GIS. Your course coordinator, Engineer Ankur, is giving you this opportunity to learn from the beginning to very higher level through this faculty development program. So really, this is very good area of the study, very good area for career promotion also. The next question is, who may use GIS? Basically, in my opinion, anyone is using GIS. Government, as government authority, I am using. Industry, definitely using all these facilities. These are very effective system. And academia, all of us are from academia, we are using that. So dear participants, this is the first session. This is the session related to the fundamentals of the geographic information system. Now I am moving to the second session. I am trying to complete my presentation because any speaker who is going to extend his lecture before dinner or before lunch is creating problem to all of us. So I am just going to complete my lecture before your dinner time. For dear participants, this is the second session. In this session, we will cover the software, use of GIS in construction, and some advanced topics. As we have studied that there are several softwares available in the market. But globally now more than 60-70% GIS market is using ArcGIS software developed by the ESRI. The second software is QGIS. I am not going in detail of the other softwares, GeoMedia, Graph, GIS, Global Mapper, and so and so. We will focus my lecture only on two softwares. First one is the ArcGIS and the second one is the QGIS. Why? I will give the explanation and the logic. This is the comparison between the ArcGIS and QGIS. Basically, QGIS, we are going to study QGIS in detail because QGIS is open source software, and in my opinion, this software is capable to cover our almost all projects. If we are not going to execute very big or very precise project, then QGIS is the sufficient for our project and purpose. The next point is that the most important point for the QGIS is that as this software is open source software, you can tailor the software as per your requirement. Very interesting point. You can change the software by yourself as per your requirement, because there is no any license, there is no any copyright of the software, about the software. So QGIS is open source software. We can use this software for almost all our purposes, and we can tailor this, we can change this software as per our need. The next software is ArcGIS software. Definitely, this is very good and very efficient software. All our major projects like smart cities and sorry, urban development planning are are monitoring the big projects. We are using the ARC GIS software. Here, I could not share the facility of the ArcGIS, though we have the ArcGIS, but due to limitation of the license, we could not share the ArcGIS. But definitely, I will give you the training of the QGIS software. Pros and cons of the QGIS. I am not going in detail. You can go through. I have written in very simple manner, so anyone can understand the pros and cons of the QGIS. All these are the advantages and disadvantages of the QGIS. Again, I have listed pros and cons of the ArcGIS because uh, uh, IFRI is working on the improvement of the ArcGIS. Definitely, the software is really very good, but again, IFRI is working to update the software as usual. So these are the pros and cons of the ArcGIS. Now I am coming on the part working with GIS software. As I told earlier, that I will give you the process of the working of the QGIS software. As Professor Dr. Agrawal said in inauguration session, that QGIS software is open source software. He mentioned the downloading of the QGIS. Now I am giving the link and the source of the downloading the QGIS software. This is the process of the downloading the QGIS software. You can download this software just by clicking the website. And what will be the process of the working in the QGIS? I have described how screens will come one by one. Uh, I have prepared the slides. So you can download if you have facility at this moment. You can download after my lecture because I am going to cover other topics also. But I have summarized the complete process of the downloading the QGIS software and the working in the QGIS software. All these are the steps you will find in the downloading process and in the working process. Now, GIS in construction. Here I will try to cover two areas. One is GIS in construction. I will describe the generic details. And the next is the GIS in GIS in civil engineering or in construction, implemented by us. So that during implemented project, I will give you the details of the algorithm of the working in the GIS because this is the challenge. How anyone can start working in the GIS from zero to top, from inception to the uh, execution means to the preparation of the reports. So just I am uh, going some uh, uh, going to describe some points in brief to save my time for the implemented project. So geographic information system is being used from the inception of the project, from the planning of the for the planning for the inception of the project, for the planning of the project, from the monitoring of the project, for the maintenance of the project, for each and every stages of a project, we are using GIS. As I discussed, that GIS support to take the good decision, best decision depending on the available data. We can plan the best route for the expressways, best route, best route for the national highways, or even for urban development. For all these, we may take the advantages of the GIS.
చేసింది చేసు తాత డ్యూటీలో ఉన్నారు కదా బిజీగా మాట్లాడుతున్నారు ఎవరితోనూ.
I'm speaking. I am skipping some slides to save the time because I have prepared slides to describe each and every construction area in every
Everyone kindly
stages
mute
of the
yourself.
construction just by using the GIS. So I am just skipping to give the details of the methodology of the working in the GIS. You can go through all these slides to have idea of the implementation of the GIS in different construction areas. For example, for infrastructure planning, we are using GIS. For traffic planning, we are using GIS. For urban development planning, we are using GIS. And let me say, for day-to-day monitoring, we are also using GIS. For watershed management, we are using GIS for transportation planning. For environmental analysis, just my previous expert has given the climate change and all these use of GIS in assessment or study of in the area of climate change and space utilization. Basically, through GIS, we can optimize, we can best utilize our resources, our existing resources. Not only land, but all our resources could be best utilized just by using the GIS. Now I am coming on the third session, that is implemented the project. Basically, just give me one. Basically, through this session, I am trying to describe the methodology, the working procedure, or let me say, the algorithm of the working in GIS. So, the stages in GIS projects. Whenever I will correlate these theoretical descriptions in my implemented project, basically, what are the stages? This presentation, this session is devoted for the beginner of the GIS. So, any beginner may have question, if I will have to work in the GIS, what will be the steps? How we will proceed in the GIS project? So, what are the stages in GIS project? The first GIS project step or stage is define the project objectives. Inception of the objective, the inception of the project objective. The first step, identify the purpose, clearly outline the goals and objectives of the purpose. What we are going to achieve through this project, through this work. So this is the first step. Define the project objectives, scope of work, specify what are the project will cover, and the expected outcomes. This term is very important, expected outcomes, because our reports will be generated to serve the purpose of this outcome. GIS has the special feature to prepare and to present the reports in the different formats. For example, if we have digitized the map, then we are able to print the map, prepare the outputs, prepare the reports at different scales. For example, if we have a survey map of a district, just like I am giving just a number to quote example, 1:10,000, then that is fixed. But in the GIS, if we have digitized the map, we can convert it as per our requirement. So here it is very important to define the scope of work and the expected outcomes. The third one is stakeholders. Identify the stakeholders and their requirements. As Professor Dr. Agrawal said in his inaugural session, if we have other purposes, other stakeholders, then we will go for the different data sets. Then we will go for the different software. Then we will go for the different people. Sorry. So here we will have to decide all these three, because based on these requirements, based on these objectives, we will move further accordingly. For example, Depending on our objectives, we will collect the data. For example, if we have to plan a highways, then we will collect data with different resolution. And if we will have to plan a city development, then we will have to capture data with different resolution. So the next point is data collection, primary data, secondary data, and the data types. Very interesting. All of you from academia, so definitely you may have very good idea about the primary data. I am not going in detail of the in defining the primary data and the secondary data. We have just briefed the different data types. So depending on our objectives, we collect the data. The third stage is data preparation and processing. It is very interesting, sir. Data cleaning. Data cleaning. When we collect data, whether by satellite imagery, remote sensing may have several systems, satellite imagery, aerial photographs, drone, all these are the sources of data for the GIS. All these are the remote sensing systems. Drone, aerial photographs, radar, or satellite imagery. Then we do the cleaning of the data, redundancy, superfluous, or irrelevant data may be deleted. The next stage in the data preparation and processing is the format conversion. Because we receive the data in different formats, but during the GIS working, we will have two data in a different format. So we convert data into GIS compatible formats. I am not going in detail at this point. Just try to understand, we convert our data in our desired format. The next point is projection and coordinate systems. Standardized. When you will start the working in QGIS, the first step will come to standardize the coordinate system and map projection. The fourth point in this is that integration, combine data sets from various sources, ensuring consistency. Because if we are collecting data from the different sources, from the different mechanisms, some data is from drone, some data is from satellite imagery, and even some data, if data has been taken through the mobile, then we try to integrate all these data in one system to develop the consistency among the data. The fourth stage is database creation. What is database creation? That is data storage. This is very good feature, very good feature of the GIS. What I am saying, that GIS has the capability to store and analyze big data. Nowadays, we are working in the with the big data. Sorry, for young faculty, I'm just quoting. During our initial stage of career, we were constructing primary schools as government engineer, primary health centers. The tallest building I was constructed in my initial service period was the single story building. So try to compare the data size of those construction, and nowadays we are working on very high-rise structures, multi-storied buildings having more than 100 stories. Fortunately, I am taking this session from the FERC, Chennai, CSR, CSIR, FERC Center in Chennai. I am here to give some lecture, some interaction on the structural health monitoring and the impact of the different loadings on very high-rise structures are very heavily loaded railway tracks. So, try to understand the challenge of these days engineers. They will have to deal with very big size data. So GIS has the capability, has the unique feature that GIS can store, manipulate, not just manipulate in sound system. This is the technical term. To analyze and then can store, analyze, and can produce reports as per our requirement. So GIS has the facility to handle the very big size data. Data organization. We store, we organize the data in our implemented project. I will again focus how we organize the data. And then the metadata documentation, record metadata for data sets, including sources, accuracy, and date. The next point of the GIS working is the spatial analysis. This is the important. Basically, all parts are important. Visualization, create thematic maps to visually represent the data. Basically, all these are dependent on our objectives. When we define our objectives, we execute GIS working as per our requirements. So here, visualization, geoprocessing, and modeling, all these are based on our objectives. So here we will do three works. First one is the visualization. Second one is the geoprocessing. And the third one is the modeling. Fortunately, nowadays we are receiving georeference data from different sources. But in our earlier age, we will have to georeference our data. The next stage of the GIS working is interpretation and validation. Result interpretation, analyze the outputs and validate, because any result should have a genuine validation. Today, even in our FERC meeting, we have discussed the validation of our study. So analyze the outputs and validate them against the project objectives. Field verification, if there is any necessary to take the data, to take the confirmation from the ground. We may say that ground truthing, conduct ground truthing to verify the accuracy of the results, and the stakeholders feedback, share preliminary results, with stakeholders for review. The next stage is report and presentation. What I am saying that GIS has the capacity to prepare reports as per our requirements. Map production, documentation, presentation, we can prepare reports as per our requirements. The next is the implementation and decision making. Here again, I am repeating that GIS has the unique facility to support to take the best decision depending on the available data. Maintenance and updates, data updating. If we are working in a dynamic project, for example, we have worked on the face assessment, labor face assessment as per BOCW Act, Building and Other Construction Workers Welfare Board Act. Then this process is dynamic process. We can't say that each and every building, each and every property and construction has been covered under this work, because the construction is dynamic. So we do the updation of the data, we do the dynamic analysis, we do the reporting as per requirement or as per schedule. System maintenance, performance monitoring. Sorry. So this is the methodology. Based on this methodology, I request all participants to just keep these methodology in their mind so that they could visualize, they could correlate the methodology in the implemented project. So I have taken one example. Definitely, I will delete some slides for public domain. But here, just to give you the lecture, I am giving the entire slides. So we have worked one GIS-based project for the Lucknow Industrial Development Authority, LIDA, that is under the Department of Urban Development, Government of Uttar Pradesh. So what is the name, what is the objective of the project? Try to remember my first step. In the first step, I have discussed define the project objectives. This is the first step. Then in project implementation, this is the name of the project. Means defining the objectives. Defining the objectives of the project. GIS survey of the LIDA region. Why I have taken this project? Basically, this project is very important, and this project covering the almost all aspects of any development. Because in urban development, we may have land details, we may have property details, we may have infrastructure details, but in several projects, we may not have the contours and the levels of the ground, of the land, of the concerned land. But here, we have worked on the physical features with the levels, contours of the assigned area, so that we can plan the surface infrastructures, roads, buildings, commercial buildings, or other requirements with the precise planning for the sewerage system, because we will have to level contours of the entire area, and drainage system, to supply system, pipe supply system. So I have taken this project to describe. So the objective of the project was GIS survey of LIDA region with the help of quick bird high resolution satellite images, because government was interested to have very precise information of the property for the infrastructures and for the contours and the levels. So we mentioned the type of the data, type of satellite to acquire the data. For the generation of detailed large scale maps, shifting of the planimetric details, cadastral boundaries, micro-level land use, using the state-of-the-art technology of GPS, image processing, and digital data capture using 0.5 meter resolution, pan-sharpened color imagery, or any better resolution images supplemented by the ground truth collection. This is the objective of our LIDA project. Uh, the next, we have detailed the objective, scope of the work. In scope of the work, we have described several small activities. We break up the entire objective in several activities and sub activities. First activity was to review of the existing situation and then procurement of the high resolution data. Next is the design of proper grid, because grid design is important because it is very problematic to 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 study the entire area at one time. It is very difficult to send the surveyor for ground truthing, having the complete drawing or satellite imagery to one surveyor. So what we do, we cut the satellite imagery, or we cut the entire area into small squares. That squares are grid. So design a proper grid and projection of the whole town, geocoding and georeferencing. This is the important, because in those days we have not georeferenced the data. Nowadays, we are privileged that we have georeferenced the data. All these are the activities related to our objectives. This is the working steps defined jointly by our organization, Construction Industry Development Council, that is body of Planning Commission, now Niti Aayog, Government of India. So all these steps had been decided jointly by our organization and the government of Uttar Pradesh. So all these are the working steps. No need to worry. All these steps are related to our methodology, our algorithm. So I am skipping all this. This is the procurement of high resolution images. We received in India, we receive satellite imagery only through the NRSC, National Remote Sensing Center. And fortunately, I have the authority from my organization to take the satellite imagery for the government projects. So this is the satellite imagery we have received from the IRSC. This is the satellite imagery having the LIDA boundary. This is the satellite imagery. We have implemented the grid plan. Grid plan means the square area, so that we can handle that area very conveniently. So this is the ground control. This image is grids with ground control points, GCP. These are the latitude and longitudes of the ground control points. We established several ground control points to coordinate, to coincide, even to check, or let me say, to validate the findings of the GIS reports. So, here I will describe the satellite imagery of grid number 12. We have prepared 42 grids, but for this study, I will just consider only one grid, that is grid number 12. This is the second activity. As we have said, that we have distributed, we have divided the objective, our main objective, in several activities and then in several sub activities. So this is the second activity with sub activities. This is the digitization of grid number 12. What I told earlier, this is the theme of the GIS, that we receive data in the form of raster, but we work uh, in GIS on the data in the form of vector. So what we do, we transform the raster data into the vector data. That process is the digitization. We take the data as per our requirement, as per our need. We digitize the data as per our need, as per our requirement. So here we will have to prepare the base map, master plan for the urban development planning, for the planning of the Lucknow Industrial Development Authority. We have digitized the satellite imagery as per our requirement. So we are going to study the digitization. This is the complete digitization plan. Earlier, I have discussed the thematic layer. Basically, GIS works in the form of layers. GIS stores data in the form of layers, not very precisely, just to visualize that the beginner can understand layers as the map, not very precisely, map or drawing of any theme. If thematic layer means layer, map or drawing having objects of a particular theme. For example, this layer, this layer having the all buildings existing in the LIDA area. This layer is uh, is uh, owning the all buildings of the LIDA. For example, this layer this layer is comprising of all residential buildings. All residential building. This layer is comprising of all commercial building. So here we are using one theme, commercial building, layer of commercial building. So this is a thematic layer, a theme, commercial building. So we digitized the commercial building in this theme, in this layer. So again, this layer having the educational building, this uh, so try to understand this layer having the all buildings. This layer is comprising of residential buildings only. This is commercial buildings. This is the educational building. What is the best feature of the GIS? Whenever we complete the digitization, we may have several layers. There is no any limitation of the creating the layers in the GIS. There is no any limitation. You can create any numbers of layers having any type of tree. The advantage is that GIS provides us the facility to to link one layer to two layer, or one theme to two theme, or one, let me say, one to many, many to one. For example, we can analyze all buildings, we can analyze only residential buildings, we can analyze commercial buildings, again, we can analyze educational buildings, we can develop interlinking. For one layer, we can see that all commercial buildings and educational buildings means non-residential buildings. And one layer having the residential buildings. All in another layer, we can say that the buildings 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 having 100 square meter area or more than 100 square meter area. Like so we can integrate one to one to many, many to one, many to many, many to one. So this is the digitization. This is the digitized routes in grid number 12. This is the metallic roads, metal roads, permanent roads, and this is the unmetalled roads in grade 12. Again, we can interpret, we can link metalled road with the unmetalled road or unmetalled road with several other features we can interlink. This is the Kharanja road in grade number 12 of the Lucknow Industrial Development Authority. This is the water bodies layers having the water bodies like canal, nala, ponds, etc. This is the base map. This is the complete digitized grid number 12, having the temporary benchmarks, having the contour lines, having the ground level. So, dear participants, this is the portion of digitized grid with ground level, TDM and control lines. We can see the each and every spatial and non-spatial data information is available in this way. So we can use this information in our urban planning. We have taken a benchmark from Lucknow airport, from Lucknow airport. LIDAR TVM details. In this project, we have developed one more system, very effective system, that we superimpose the existing maps, revenue maps, village maps on the latest digitized maps, so that we can see the changes, we can study the changes, we can incorporate the concept of the authorities in the ground, and we can trace the unauthorized construction, unauthorized capturing the natural resources, or unauthorized capturing the government properties. And just after the superimposing of the existing Sajra maps, older Sajra maps, village maps, to the latest or current digitized map, we have solved several encroachment problems, unauthorized captures. Even authorities have used these superimposed maps to solve the revenue disputes. Though solving revenue disputes were not our objective. Digitized revenue maps, Fajra maps, grade number 12. All these are the Fajra maps, digitized maps with superimposition of the existing Fajra maps. This is the base map, final with revenue boundaries. This is really very big and challenging job to mark the revenue boundaries of villages and the properties. Now, I am requesting course coordinator, engineer Ankur, to open the session. If there is any question,
I invite all the participants. If there is any question, we are now open for the query.
Good evening, sir.
Good evening, madam.
Sir, I have a question.
Yes, ma'am.
Sir, I'm Dr. Swati from ERA University, Lucknow. Sir,
Okay.
I want to ask how we can use this GIS technology for monitoring or studying pollution in the agro ecosystem.
In fact, this topic could not be covered at this moment because your course coordinator has planned different sessions for the different topics. Definitely, Engineer Vankur will give you the details. Because if I will go to cover the implementation of GIS in the health monitoring or environmental impact assessment or what you are saying, then again it will take half an hour or more than that. So I just requesting every participant that this is the presentation of the fundamentals of the GIS and the working describing the working methodology of the GIS. So your question, I am transferring your question to the course coordinator engineer Ankur. Sorry that due to time limitation, I could not explain the other area of study.
Ma'am, there is one session on water management and all. You can raise their question. I guess you will get the answer there. We have more sessions.
Okay, thank you so much.
Anyone?
Engineer Ankur, I am expecting that everyone is waiting for
Dinner.
dinner.
Okay.
So don't ask more questions. Try to complete the session.
Thank you.
And really, Engineer Ankur, I am very grateful, and I am extending my sincere gratitude to you, to your institute, Buddha Institute of Technology, Gorakhpur, and the All India Council for Technical Education for organizing this excellent and well demanded faculty development program. Ankur, just I want to quote one thing. Today, in the meeting with the FERC director, Dr. Annapule, we were discussing that industry and academia relation is relation having some issues. Industry is not transferring the knowledge to the academia, or academia is not, let me say, I am not using any negative term. Academia is not matching the pace of the requirement of the industry. So really, as our whole society is being transformed to the GIS, then really this is very much needed faculty development program in the area of geographic information system. So on behalf of my organization, Construction Industry Development Council, I am again extending my gratitude to you, to your team, and the all participants. Thanks, Engineer Ankur.
Thank you, sir. It's our pleasure to have you. And you shared each and every detail in a very crisp manner. So I'm very thankful to you that you accepted my invitation and you promptly replied to my mail. Thank you so much once again. And I'm also looking forward to some of the more fantastic sessions in upcoming future. So once again, thank you so much. And to all the participants, I have shared the feedback link of day one, both the session. It is mandatory to fill the feedback form because your attendance will also marked and it will also it is also equally important in terms of your certificate. So please do not miss any session. You have to be present in every session, and at the last day, you have to give a test also. So thank you for such a wonderful audience for patiently listening to all the PPT shared by our both the speaker. and not disturbing at any time. So thank you so much. Thank you once again. Now you all can leave as it is dinner time. So I will not take much more time. Thank you so much. Good night, sir, and good night to everyone.
Good night.
Thank you so much, sir. Good night.